Welcome to Well Explained. I'm here once again with the chapter Electricity of class 10th. Now, what is electricity? When the word electricity comes to your mind, you just think of the bulb, fans, television, radio, ACs, etc. etc. All these appliances, they work on electricity. Electricity is actually a type of energy, and it is very important nowadays because without electricity we are not able to live. Why? Because our comfort, we are at very comfort, very ease with the help of many appliances which run on electricity. This electricity is actually the flow of charge. So first of all, we'll come to know what are charges, what is a charge. Charge is the inherent property of matter. We know what is matter. Matter is anything which occupies space and has mass. And we also know that matter is made up of very tiny particles which are known as atoms. An atom in turn, they are formed of three subatomic particles: protons, neutrons and electrons. The charge is the inherent property of matter that feel force of attraction or repulsion due to the excess or deficiency of electrons. Means the charges are of two types: positive charges and negative charges. We know atom is electrically neutral, but somehow the atom has to either lose electrons or gain electron. Whenever an atom gains electron, it gets a negative charge, and whenever it loses electrons, it gets a positive charge. So there are two types of charges: positive charge and negative charge. The SI unit of charge is coulombs, which is denoted by the letter capital C. This charge is detected and measured using a device called as electroscope. You have studied about charge in your class 8. They were the static electricity, and in that class, in that chapter, you have learned about electroscope. We know when two objects, they are rubbed. As in first case, uh, the electrons rubbed onto ebonite rod. This ebonite rod is rubbed against fur, and we can see the electrons, they are rubbed onto the ebonite rod. That means electrons are more on the ebonite rod. In the second case, the positively charged plate is attracted to the negatively charged rod because the unlike charges, they attract each other. In the third case, electrons rubbed off the glass rod. That is, glass rod is rubbed against silk cloth, and the silk cloth gets negative charge, leaving it positively charged. Now this is an electroscope. You don't have to do with electroscope in your class 10, but it's for revision. That electroscope consists of a metal disc, that bottle, glass bottle is there, the cork and copper wire, and at the one end of the copper wire is aluminum foil is there. So whenever a charged body is brought near the metal disc, the aluminum foil, either they repel or they get attracted. Now what are the properties of charge? Electric charges, they occurs naturally. There are two types of charges: positive charge and negative charge. Each charge has an electric field associated with it. Charges interact through this field. As the magnet around it has a magnetic field, in the same way, the charge has an electric field around it or associated with it, and the charges, the positive and the negative charges, they interact through this field only. The charges exert forces on each other. These forces can be the force of attraction or this can be the force of repulsion. The two like charges, they repel each other. That means here what is the force of repulsion is acting. Whereas two unlike charges, they attract each other. Here the force of attraction is acting on the two charges. Two like charges repel each other means if two negative charges will be brought together or two positive charges will be brought together, they will repel. In the same way as in case of magnet, two like poles, that is north-north or south-south, they will repel. Whereas the two unlike poles, that is north-south, it will attract. So two unlike charges, that means if a positive and a negative charge will bring together, they will attract. If two positive charges will be there, they will be repelled. Like mass, momentum, and energy, charges are also conserved. That is, charge cannot be created nor destroyed. The total charge of an electrically isolated system remains the same. Now, what is electricity? Electricity is a form of energy that can be easily changed to many other forms. As we can see many appliances in our home. We have fans which runs on electricity. In that electricity is converted into mechanical energy. That is electrical energy gets converted into mechanical energy. In fridge it is heating or cooling. Means in fridge it is cooling, whereas in iron, oven it is heating effect. Electricity is also used for communication. Our laptops, computers, mobile phones, tablets, radios, television, they all run on electricity. Electricity gives us light also. That means electrical energy can be converted into light energy, as in the case of floodlight, flashlight, lamp, incandescent light, etc. etc. And electricity can be used for motion or power, as in the case of motor, drill, blender, cars, etc. etc. There are so many uses of electricity. Electricity is also used to run heavy machines. The train, the electric trains, metros, they all run on electricity. Now, what is electric current? We know electricity is the flow of electrons, the electric charge, especially the negative charge. So it is the rate of flow of electric charge or electrons through a conductor. That is I, that is the current, is equal to Q, that is the charge upon time. That is the rate of flow of electric charge means how many charge flows in 1 second. Electric current is a scalar quantity, that is it has only magnitude but there is no direction. The SI unit is coulomb per second, or it is also known as amperes. Electric current is measured by a device called ammeter. Its direction is taken opposite to the flow of electron. It flows as a result of potential difference across the ends of a conductor. Now, electric field. It is the three-dimensional space around a charge in which the force of attraction or repulsion can be felt. Suppose there is a positive charge. This charge will have a three-dimensional space around it, and if a positive charge is introduced in this electric field, it will have the force of repulsion, and if a negative charge is introduced in this electric field, it will uh, have the force of attraction. Now, electric field intensity. It is the force experienced by a unit positive charge when placed in a magnetic field. It is denoted by capital E and its SI unit is Newton per coulomb, and it is a vector quantity because it has magnitude as well as direction. Now, what is electric potential? Potential means the capacity, how much work you can do. As here the electric potential means it is the work done, amount of work done in bringing a unit positive charge from infinity to a given point in the electric field. It is a scalar quantity. Its SI unit is joule per coulomb or volts. What is electric potential? The amount of work done in bringing a unit positive charge from infinity to a given point in the electric field. And what is potential difference? It is the same thing, one and the same thing as electric potential, and potential difference is one and the same thing. The only difference is that the charge is brought from infinity to a particular point in electric potential, and in potential difference the charge is brought from one point to the other point. So it is the amount of work done in bringing a unit positive charge from one point to another point in an electric field. It is also a scalar quantity. Its SI unit is same as of electric potential, that is joules per coulomb or volts. This potential difference is responsible for the flow of current in a conductor. Means more the potential difference across the uh, terminals of a battery or a cell, more current will flow. It is measured by a device called as voltmeter. Now, when it comes to the flow of electric current, all the material fall into three categories. Till now, you have studied either there are conductors or there are insulators. Insulators are those substances which do not allow the electric current to pass through them, such as plastic, wood, etc. Whereas conductors are those substances which allow the current to pass through them or to flow through them easily. For example, all metals. Along with these insulators and conductors, there is one more category of the objects or substances which is known as resistors. Resistors opposes the flow of current through them. They allow only some amount of current to pass through them. But the current which is passing through them, that gets converted into different forms. We are going to study in the later slides. Now, insulator. Any material that does not allow electric current to pass through it is called as an insulator. Like the protective coating on wires, you have seen electric wires, they all are covered with plastic, rubber, glass is also an insulator, cloth is also an insulator, dry cloth, and wood is also an insulator. Now, insulators like plastic and rubber, they are used as a covering for electric wires. And this makes electric wires safer to handle because the insulator protects you from the current. You must have seen the electrician when it comes to your house. So the various things, screwdrivers, pliers, and he also used to wear the rubber gloves also. That all instruments are having, all devices he is having has insulation either of plastic or of glass. Now, conductors. Any material that allows electric current to pass through it is known as a conductor. You can see in this figure there is a wire. If you peel out the plastic covering, take out the plastic covering, you will see the metal wire coming out of it. That is the conductor, and the plastic covering is the insulator. The examples of conductor are copper, aluminum, steel, or any metal. Conductive material, that is metal, is used for wires that will carry electricity. Now, what are resistors? A material or a device that allows some current to pass but converts some of the current to another form of energy are known as resistors. For example, these appliances, bulb, guitar, they have resistors that convert electrical energy into light energy. Actually, this is the neon sign bulb. The electricity that is passing through this, it gets converted into light energy. These appliances that you can see, they have resistors that turn electrical energy into motion energy or mechanical energy. Now here is the set of appliances. These also have resistors that change electrical energy into heat energy. Heater, hair dryer, oven, toaster. Now these appliances have resistors that convert electrical energy into sound energy. Telephone, guitar, headphone and tape recorder. Now comes circuit. What is a circuit? Circuit is actually a path for electric current. Path for electric current means it comprises of conductor, switch, source of electric energy, and it provides a continuous path for the flow of current. You can see this simple circuit with light. You must have studied it in your class 6. An electric circuit might be open or closed. To open or close a circuit, you all have studied what we use. We use a switch. Now closed circuit. Closed circuit is an unbroken path for electric current. Means no gaps. When there is no gap, that means circuit is closed and the current can flow. You can see in this simple circuit with light, the battery or the cell is connected to the CFL with the help of conducting wires. As there is no gap, the light is on. Open circuit. A path for electric current that has a gap. Gap means no current can flow. You can see in this simple circuit, there is a gap and the light is off. Now coming to Ohm's law. Ohm's law was given by George Simon Ohm. And according to Ohm's law, at constant temperature, the amount of current flowing through a conductor is directly proportional to the potential difference across its ends. We denote current with capital I. We denote potential difference with capital V. So according to Ohm's law, I is directly proportional to V. Or we can say V is directly proportional to I. Means more potential difference means more amount of current will flow through the circuit. For removing or substituting the proportionality sign, we use a constant, and in this case, the constant that is kept is resistance. The equation becomes as V is equal to IR, where R is the constant called resistance, V is the potential difference, and I is the current flowing through a conductor. According to this law, conductors are divided into two categories: ohmic conductor, which follows this Ohm's law, and non-ohmic conductor, which do not follow Ohm's law. If we draw this IV graph for conductors, we have said they are of two categories which follows the Ohm's law. They are known as ohmic conductor. In this case, if we take the potential difference on the x-axis and the current flowing on the y-axis and we draw the graph between these two, then it will be a straight line. Means ohmic conductors show a straight line when the graph is drawn between I and V, that is current flowing through the conductor and potential difference across the conductors. But for non-ohmic conductors, this IV graph is a curved line. So that's all for this lecture. We'll meet with new content, new lecture. Thanks for watching. Have a nice day.